Part 2 of Historical Hypothetical Mysteries. T-Rexes likely had a single-chambered stomach with a gizzard, a muscular organ that would grind food internally. Gastroliths and digestion. The gizzard in birds often contains stones, known as gastroliths, that aid in the mechanical breakdown of food. It is possible that T-Rex swallowed stones to help grind up bone and other tough materials. Is it plausible to say that Trexes support fire breathing except for the facts? They cannot support combustion sufficiently without wasting large amounts of energy and/or using it as a last resort self-defense mechanism. Like how a bee will die from stinging a Trex with get severely injured or die from fire breath. Combustion giving evidence that all it takes for fire breath to occur is two stomach chambers, one specialized for holding gas and one specialized for ignition. Well, the gizzard could hold metals like steel and rocks like flint. All it would take is specialized tissue that doesn't absorb methane produced from the gut into the bloodstream, and that is fire-resistant. The fact that Trexes breathe oxygen plays a role in combustion, adding to the fact that they have a regurgitation muscle and a reflex that could trigger the expulsion of the flame out of the gut through the mouth. So, with this newfound thought, would this evolutionary trait work with the supporting stuff? That's an interesting idea. Here's how those factors could potentially interact. Hollow bones and respiration. Hollow bones, like those found in birds, are connected to the respiratory system with air sacs. This provides a more efficient way to get oxygen. The air sacs extend into the bones, allowing for a greater surface area for gas exchange and a unidirectional flow of air through the lungs. Lungs with minimal blood vessels. If the lungs evolved to have fewer blood vessels, it would indeed reduce the amount of oxygen absorbed into the bloodstream directly from the lungs. Trade-off and compensation. If an animal with hollow bones and air sacs also evolved lungs with minimal blood vessels, it could work if the respiratory system as a whole compensated for the reduced oxygen uptake in the lungs. The air sacs in the hollow bones would need to be highly efficient at extracting oxygen to make up for the lungs' reduced capacity. Evolutionary pressure. This kind of evolution would likely occur if there was strong selective pressure favoring reduced blood flow in the lungs for some reason. For example, if the animal needed to minimize the risk of absorbing toxic substances from the air, or if it needed to store gases within the air sacs for other purposes, like buoyancy or vocalization. In summary, while it's not a straightforward advantage, it's plausible.